Hello everyone. In the last class, we had discussions on belt drives, the concept under that module number 4, and in that transmission, power transmission part. So next, after that belt drives, we have that next concept, that is gear drives. So let us see what is this gear drives and how this gear drives will be helpful in transmitting power from one point to another point. So we will discuss all these things in detail. Again, we will discuss the types of gear drives, and next we have that gear trains and all those things. So let us see one by one. So first go with the basic introduction for this gear drives. So let us see what is gear drives now. Gear drives are toothed wheel used to transmit considerable power over a short distance positively with a constant speed ratio. So this is why that gear drives will be made use. These are the toothed wheels, means the wheels on the periphery of which the teeth are cut actually. So those are the toothed wheels used to transmit the considerable amount of power over a short distance positively with a constant speed ratio. So this is one more important thing here. It is used to transmit some considerable amount of power over a short distance, that is only for small distance. When the shafts are of within the small distance, then you can make use of these gear drives to transmit the power positively with a constant speed ratio. With the speed ratio will be maintained constant actually. So that is what actually gear drives. So these are the toothed wheels used to transmit that power over a short distance positively with a constant speed ratio. So we'll come to know what is that short distance, why we will make use of this gear drive for a short distance, power transmission in short distance. Here next let us see what is that gear and how that gears will be mounted on the shaft, and then how the power will be transmitted from driving shaft to driven shaft. So this is regarding basic like a basic thing for gear drives. They are the toothed wheels used to transmit that power over a short distance positively with a constant speed ratio. Next you can see what is that gear. Gear is a toothed wheel with teeth cut on its periphery. This is what I said. A gear is a wheel on the periphery of which all teeth are cut. So that is why we just define that gear as a toothed wheel with the teeth cut on its periphery. Next, these gears are mounted on shafts and keyed to them. These gears will be mounted on that shaft, and that gears will be attached, firmly fixed, or you can see it as keyed to that shaft on which the gears are mounted. And then the two gears mounted on one each of the driving and driven shaft are arranged so that the teeth of one will mesh with the teeth of the other. That is, the two gears, out of which one gear will be mounted on driving shaft and one gear will be mounted on driven shaft, and those two gears will be arranged in such a way that the teeth of one gear will mesh with the teeth of other gear. I will show you a simple example how that gear drives will look like. So those two gears which are mounted on driving shaft and driven shaft will be arranged in such a way that teeth of one gear will mesh with the teeth of the other gear. So thereby which the rotation of one gear will cause the rotation of the other in the opposite direction. I think you might have seen that gear drives, how the rotation will be taking place in case of gears. So this is regarding basic introduction for gear drives. Simple thing, gear drives are the toothed wheels used to transmit that considerable amount of power over a short distance positively with a constant speed ratio. Next, gear. Gear is a toothed wheel with teeth cut on its periphery. Then these gears will be mounted on that shaft, and the gears will be firmly fixed to those shafts actually, or you can say it as the gears are mounted on the shaft and they are keyed to those shaft. Then those two gears mounted one on each of the driving shaft and the driven shaft will be arranged in such a way that teeth of one gear will mesh with the teeth of the other gear, and the rotation of the driving gear will cause the rotation of the driven gear but in the opposite direction to that of driving gear. So that is how this gear drives will work, and that is how the power transmission will be taking place. So next we will see that some of the gear terminologies which are very important. These gear terminologies actually. And we have two diagrams for this. This is one that I wrote in the notes actually, and here we have one more diagram. I have taken it from the internet. So here these two diagrams are almost similar. Even the parts which I have mentioned here, they are almost similar. Only thing is that I will tell you what is the difference here. One thing I have missed here because I could not show that line. That is one line I could not show here because that was intersecting with this line. That is this line which is used to which is taken as reference for this end point of this gear teeth. So just because of that I could not show that line. No problem. I will show that with the help of this line or this diagram, or else if you can take this thing as that circular. You can take this as pitch circle only. I will tell you what line is missing, and we need to take this line as a pitch circle. So first thing is pitch circle. The main terminology is pitch circle. So you can see here, it is a theoretical or an imaginary circle upon which all the components are made. So remember that this pitch circle is an imaginary circle, or you can say it as a theoretical circle. You cannot see that pitch circle on the gear actually. It's a imaginary or a theoretical circle upon which all components are made. That means by making use of that pitch circle as a reference, we will design all these remaining things actually. And or you can say it as by taking that as the reference, that is pitch circle as a reference, all the other parts will be designed and built. So that is called as pitch circle. You can see in this diagram I have pitch circle here. So the name itself clearly given. This is a pitch circle. It's an theoretical or imaginary circle on which all other components are made. Here you can please take this as pitch circle. I have not given a name for that pitch circle because it was overlapping with this reference line which was drawn for this, which connects these other edges of the teeth. So here you can take this as pitch circle. It's a theoretical or an imaginary circle upon which all other components are made. That means by taking that as a reference, they will design this, what is the size of this part and what is the size of this part, what should be the size of this part, and all those things. So it's a imaginary circle upon which all components are made. Next is pitch circle diameter. It is very simple. Once you know what is pitch circle, then pitch circle diameter is diameter of this imaginary circle. So that is what they are telling here. It is the diameter of that pitch circle. So the gears are, as we said, it's a toothed wheel actually. Wheel is in the circular shape, you all know that. So the diameter of that imaginary or a theoretical circle is called as diameter of the pitch circle. That is pitch circle diameter. Next is pitch. This is very important thing actually. Pitch. You need to remember what is the definition of this pitch here. It is the distance from a point on one tooth. I will take one point on one tooth here. So this is one tooth. I will take this as one point on this tooth, and even you can see this on this diagram. I have taken this as one point on this tooth here. It's a distance from a point on one tooth to the corresponding point on the next tooth. So corresponding point on next tooth is this thing. If you take this point on this first tooth, next corresponding point on the next tooth is this one, definitely, right? Or else if you want to take somewhere here, you can take this as one point on this tooth, and you need to take the corresponding point on the next tooth. That means it will come to this side. So you need not to show it itself. You can show here also, no problem. That is, thing is actually it should be the distance from one point on one tooth to the corresponding point on the next tooth measured along the pitch circle, and that has to be measured along this pitch circle. This is the pitch circle we already taken here. I think you can see here. This is the pitch circle we have taken it here. So this should be, that is this is called as pitch. That is distance from a point on one tooth to the corresponding point on the next tooth, which is measured along this pitch circle, is called as circular pitch, or simply you can call it as pitch. Circular pitch or pitch, both are same. That is pitch, as it is the wheel is a wheel in a circular shape, so we'll call it as circular pitch, or simply you can call it as pitch. That is regarding the pitch, and it can be given as, so to calculate that pitch we have a simple formula. Pitch is equal to pi d divided by t, where d is the diameter of the pitch circle, that is diameter of that imaginary circle upon which all components are made. Next, t is number of teeth, that is number of teeth of that given gear. So if you have these two data, then you can calculate what is the pitch of that. So it is pi d divided by t. Next is we have that next definition is module. Module, again you can see it is the ratio of pitch circle diameter of a gear to the number of teeth. It is very simple definition to remember. It is a ratio of pitch circle diameter to the pitch circle diameter of a gear to the number of teeth on that gear. So here they have given that ratio, m is equal, it is module is equal to d divided by t. D is again pitch circle diameter of the gear, and t is number of teeth. So same thing will make use here, and we'll write m is equal to d by t. This is module. Remember this. Next we have few more definitions. We'll go further. One thing is addendum. Addendum I have mentioned here. If you write again, I will tell you what I would like to tell you is, if you practice this diagram, then definitely you can write all these terminologies without any difficulties here. So that's why you practice these diagram with all these parts on it. If you write these things, then writing that terminologies or explaining this nomenclature is very simple. There is no difficult part in that. So next let us come to this addendum. Addendum I have shown here. You can see here. This thickness is called as addendum actually. Let us see what is it addendum now. It is a radial distance of a tooth from pitch circle to the top of the tooth or up to addendum circle. So you can see here, this is, I have written it as addendum circle. Here also in this diagram also I have shown this circle is addendum circle, and below one is, you can see here, this circle I have shown it as dedendum circle. Even in that diagram, in this diagram you can see that this one they have mentioned it as dedendum circle. This diagram is taken as dedendum circle. I have not shown this line. This is not required. You need not to show this thing. This is simply I have shown for clearance, to show the clearance. No problem. You need not to show this clearance line at all. So for that you show this dedendum circle, this addendum circle, then definitely you can write this what is addendum and what is dedendum here. Yes, let us see this addendum. It is a radial distance of a tooth from pitch circle to the top of the tooth or up to the addendum circle. Yes, this radial distance you can see here, this is called as addendum. So they are clearly telling that it is a radial distance of a tooth. This is the radial distance of a tooth from pitch circle. Yes, this is the pitch circle I have taken. So from here to top of the tooth, this is the top of the tooth. So I will take this thickness as addendum, or this radial distance as addendum. I think you all understood what is addendum now. It is a radial distance of a tooth from pitch circle to the top of the tooth, you can say, or it is a radial distance from pitch circle to the addendum circle. Both are fine. You can tell the definition in any one way, that is fine. So at least you can remember that this radial distance is called as addendum. That is the radial distance from pitch circle to the top of the tooth, or you can say it as, it is a radial distance from pitch circle to the addendum circle is called as addendum. I think the second way is best to remember actually. Anyway, we'll make use of that addendum circle here. So it is addendum is a radial distance from pitch circle to the addendum circle. That is fine. And next again, let us see what is dedendum. It is the radial distance of a tooth from pitch circle to the bottom of the tooth or to the dedendum circle. So this radial distance, that is toward downward from this pitch circle. This radial distance from pitch circle to the dedendum circle is called as dedendum, or you can call it as, it is a radial distance from pitch circle to the bottom of the tooth is called as dedendum. So these two are very simple to remember. You can write it. Even in this diagram also I have clearly shown addendum is the radial distance from this pitch circle to the addendum circle. Dedendum is the radial distance from this pitch circle to the dedendum circle. Yes, this is actually the dedendum circle. Next we will go for a few more important terminologies or nomenclatures. Yes, face is the next one. It is the surface of the gear tooth above the pitch circle. Yes, this is the gear tooth and this is the surface above that pitch circle. So that is what they have clearly mentioned here. This is a pitch circle. Surface of the gear tooth, this much. The surface of the gear tooth above the pitch circle is called as face. Here I have same thing here. This is the pitch circle I have taken it. So this is the surface of the tooth above the pitch circle is called as face. Next is flank. It is a surface of the gear tooth below the pitch circle. Yes, this is flank. Surface of the gear tooth below the pitch circle is called as flank. Next, diametral pitch. It is the number of teeth on a gear wheel per unit of its pitch diameter. So I think it was diametral pitch. It is reversed, I guess. That formula. I will make a clarification of this. I think it should be T by D. It is the number of teeth on a gear wheel per unit of its pitch diameter. Should be actually PD equal to T divided by T. I will clarify that in the WhatsApp group. Actually, will tell you this. Yes, this is regarding diametral pitch. It's the number of teeth on a gear wheel per unit of its pitch diameter. So after that, this is regarding that gear nomenclature or gear terminology. If you want, I will recall this thing once again. We'll go one by one. First thing, as you said, it's a pitch circle. It's a theoretical or an imaginary circle upon which all components are made. And this is the pitch circle. Yes, you can take this thing as pitch circle here. Next, pitch circle diameter. Diameter of that circular pitch or pitch circle. Diameter of the pitch circle is pitch circle diameter. Next, pitch. It is the distance from a point on one tooth to the corresponding point on the next tooth measured along the pitch circle. So you can see this is a circular pitch. Distance from one point on one tooth to the corresponding point on the next tooth, which is measured along the pitch circle, is called as circular pitch. PC is equal to pi d by t. Next is module. It is the ratio of pitch circle diameter of a gear to the number of teeth. Yes, it is the ratio of m is equal to d by t. Pitch circle diameter of the gear to the number of teeth. Next is regarding addendum and dedendum. Addendum is a radial distance of a tooth from pitch circle to the addendum circle. Dedendum is the radial distance of a tooth from pitch circle to the dedendum circle, is called as dedendum. Next is face. It is a surface of the gear tooth above the pitch circle, is called as face, and the surface of the gear tooth below the pitch circle is called as flank. Here also I have shown here, this is the face and this is flank. And next, after that, it is diametral pitch. It is a ratio of number of teeth on a gear wheel per unit of its pitch diameter. It should be T by D. Number of teeth on a gear wheel to the pitch diameter, T by D. So this is regarding gear tooth nomenclature or gear terminology. As I said, you practice this diagram. If you practice this diagram, you can easily write the terminology up to this point, that is up to flank. Diametral pitch is not shown here, so I think everything is shown except this diametral pitch. So write that terminologies at least up to this point. You can add this thing, even you can easily remember. This will be the reciprocal of this module what we have taken. In that module, we just take it as d by t. Remember that reciprocal of this will give you, that is t by d will gives you diametral pitch. So it is very easy to remember all this nomenclature, or you can take it as terminology. As I said, practice the diagram and mention all these parts, then writing all this nomenclature is very simple. Next, let us come to this types of gears. Gears are classified based on the position of the axis of the shaft on which gear is mounted. In the introduction, we already discussed that the gears will be mounted on the shaft. So here we will make use of that axis of those shaft on which that gears will be mounted for power transmission. As I said, there will be two shaft. One is driving shaft, another one is driven shaft. The gear which is mounted on driving shaft is called as driving gear or driver, and its gear which is mounted on driven shaft is called as driven or following. So here again same thing here, that is gears are classified based on the position of the axis of the shaft on which the gears are mounted. So we will consider how those position of axis of shaft will be, whether they are parallel to one another, whether they are perpendicular to one another, whether they are intersecting, whether the shafts are intersecting, or whether the shafts are non-parallel to one another. So we will consider all these parameters, like the position of axis of the shaft on which the gears are mounted, and by considering that parameter, we will classify the gears into 5 types, and we will see what are those 5 types here. First one is spur gear, second one is helical gear, third one is bevel gear, fourth one is worm gear, and fifth one is rack and pinion gear. So these are the 5 different types of gear, and you all know that parameter which is considered is position of the axis of the shaft on which the gears are mounted. Based on this parameter, we will classify the gears into these many types, and we will see each type in detail. Let's go for first one, that is spur gear. We have a simple diagram for the spur gear. Yes, this is the diagram you need to write for this spur gear actually. So we have a driving gear and we have a driven gear, and as we said, these two gears will be mounted on the different shaft, and one shaft here, that is driving shaft, and driven shaft will be here, and these two are arranged in such a way that teeth of one gear will mesh with the teeth of another gear, thereby which rotation of one gear will make the rotation of other in the opposite direction. So this is the simple diagram you need to write. This much is enough to show that spur gear. Don't write this 3D views and all. So here this is, you can see that this is the diagram you can write, but this is the point at which that meshing of teeth has been taking place. So somewhere here I have shown the lines, but more number of lines when compared to these positions here. These are just the teeth actually. You can see I have shown it as straight teeth on this driven gear as well as on driving gear. This is a point of contact. They will mesh, the teeth of this driving gear will mesh with the teeth of driven gear and causes the rotation of this, and thereby which power transmission taking place. And this is a simple diagram to understand this spur gear. Let us see what is that spur gear. Spur gears are the simplest and most commonly used gears designed to transmit the motion between two parallel shafts. Yes, you can see the position of these two shafts here. These two shafts are parallel to one another, isn't it? So thereby which you can say that spur gears are the simplest and most commonly used gears that are designed to transmit the motion or power between the two parallel shafts. So this is regarding main introduction regarding spur gears. Next, let us come. The axis of the driving and driven shaft are parallel to each other. Yes, this is the driving shaft, this is the driven shaft. Axis of these two shafts are parallel to one another. Next, teeth are cut straight on the circumference of the gears and are parallel to the axis. So you can see there, these are the teeth which are cut on the periphery of this wheel, and you can see there, these gears are parallel to the axis. This is the axis. This gear will be mounted on the shaft. So definitely this will become the axis of that shaft, and then these teeth are cut straight on the circumference of the gear will be definitely parallel to the axis of the shaft. Here you can see there that representation here. These are the straight teeth which are cut on circumference of that gear, and definitely these teeth will be parallel to the axis of the shaft. And next, these are used in machine tools and gearboxes, watches, and some precision measuring instruments. This is the application of this spur gear, where these spur gears will be used. They will be used in machine tools, gearboxes, watches, precision measuring instruments. So this is regarding spur gears. What you need to write is only these 4 points along with this simple diagram. Show this simple diagram and show the driving gear, driven gear, and how the teeth are cut on this circumference of the gear. Next, write spur gears are the simplest and most commonly used gears designed to transmit the motion or power between two parallel shafts. This is very, very important, as we are doing the classification only based on the position of axis of the shaft. So we need to represent clearly. So this spur gear will be used to transmit the power between the shaft which are parallel to one another. Next, you can write that axis of the shaft are parallel to each other. Teeth are cut straight on the circumference of the gear and are parallel to axis. And where this will be used in machine tools, gearbox, watches, precision measuring instrument. Next, we have helical gears. So you can see that helical gears are almost similar to that of spur gears, but only change is again that the type of the teeth, or the way the teeth are cut on the circumference of the gear is somewhat different here. Let us see what is this helical gear. And again, this is a diagram you need to write for this helical diagram, and this is that one more image I have taken from the internet, and you can see here how the gears will be meshing. Yes, these are similar to the spur gears, except that the teeth are curved or in helical shape. Yes, only difference is that these teeth are curved or in helical shape in case of this helical gears. Whereas in case of spur gears, the teeth are straight, right? The straight teeth are cut on circumference of the gear. Whereas here, the teeth are curved or in helical shape in case of helical gears. These are used to transmit the power or motion between the two parallel and non-parallel or non-intersecting shaft. So here I have shown it as parallel shaft, but this can be used, these helical gears can be used even when the shafts are non-parallel but non-intersecting. Those two shafts should not intersect, and even the shaft can be non-parallel. So in that condition you can make use of the helical gears, whereas spur gears can be used only when the shafts are parallel to one another. Whereas here in case of helical gears, you can use these helical gears when the shafts are parallel to one another, and even sometimes shafts are non-parallel, and even sometimes shafts are non-intersecting. So thereby in that cases we can make use of the helical gears. These are used when smooth and quick running at high speeds are necessary, like in automobiles. In case of automobiles, even we need to run that vehicle at higher speeds, so that in that cases we will make use of this helical gears, that is used when smooth and quick running at higher speeds are necessary, like in case of automobiles. So this will be used when smooth and quick running at higher speed is necessary. This is regarding helical gears. So please look at the diagram of this helical gear, almost similar to that of spur gear, only changes shape of the teeth. Teeth are curved or in helical shape in this case of helical gears. Here you can clearly see that. In the previous case you can see there teeth are cut straight, and whereas in case of even this is one shaft, this is one gear that is maybe driving and driven, so both of the teeth are cut straight. Whereas in case of this helical gears, you can see there teeth on this driving and driven gear, they are somewhat in that curved shape or in the helical shape. This is regarding helical gear. Next, let us, you can see here you can clearly identify the difference between the spur gear and this helical gear. In the spur gear, teeth are cut straight on the circumference. Definitely these teeth will be parallel to axis of shaft. And whereas here in case of helical gear, teeth are somewhat curved, or you can say it as these are in helical shape in case of helical gear. See, this is how the gears, teeth will be meshing here. Similarly here, the teeth of one gear will meshing with teeth of the other gear. This is spur gear, this is helical gear. I intentionally displayed this picture to make you people to understand how that spur gear and helical gear will looks like. Next, let us move to the third one, that is bevel gear. Yes, this is a diagram used for this bevel gear, and here the image taken from the internet. So teeth on conical surface. Here this surface, it should be actually conical surface. Here you can see that this should be a conical surface. Here also this surface is conical surface. Bevel gears are used to transmit the power between two perpendicular shafts whose axes are intersecting. You can see here this shaft is perpendicular to this shaft, and axis of these two shafts, this is the axis of this shaft, that is that in the horizontal direction, and this is the axis of this shaft, which is in vertical direction. Definitely axis of these two shafts will be meeting at somewhere here, right? So that is what this they are telling here. Bevel gears are used to transmit the power between two perpendicular shafts whose axes are intersecting. Yes, these two shafts are perpendicular to one another, and if you take, these are the axis. You all know that axis is also an imaginary line. You can see that this is a vertical axis, horizontal axis. They will be meeting at somewhere here. So these axis of these two shafts are intersecting. Teeth on bevel gears are cut on conical surfaces. Yes, as I said, this surface is a conical surface, and on the conical surface these teeth are cut. Similarly, on this gear also, this is that conical surface. This should be conical surface actually, and on this conical surface the teeth are cut. They are usually mounted on shaft that are 90-degree apart. Yes, you can see that these are perpendicular to one another, means definitely these two shafts are 90-degree apart, but can be designed to work at other angles as well. Not only at 90 degrees, you can design these bevel gears which can work even at other angles also. Even sometimes it may be more than 90 degree, or sometimes it may be less than 90 degree. Thing is actually like we can design that bevel gears even to work at different angles. Usually these two bevel gears, in the bevel gears, these two shafts will be perpendicular to one another and whose axes are intersecting, and in that case we will make use of the bevel gears to transmit the power. This is regarding bevel gears. Next, let us go for this worm gear. Yes, you can see that the simple diagram for worm gear, and this is that one more image you can see here. Worm gears are used to transmit the power between the driving and the driven shafts, having their axis at right angles, and but they are non-intersecting. Here also you can see there. I will clearly show you. This is the axis of this gear, and this is the axis of this gear actually. This is worm wheel, and this is a worm actually. Sorry, this is, yes, this is the worm wheel, and this is worm. The worm axis is like this, and the worm wheel axis is in this manner. They are almost at right angles to one another, but they are non-intersecting. Whereas in case of bevel gears, you might have seen this. Definitely these two are at 90 degrees to one another, at right angles to one another, but the axes are intersecting. You can see here. Whereas in case of worm gear, definitely these shafts are like having their axis at right angles to one another, but the axis will not intersect at all. So this axis will go like this, and this axis will be like this. Here you can clearly show this. This is that axis of this worm, and this will be the axis of this worm wheel. Sorry. So like, yes, they are right angles to one another, but they are non-intersecting. Next, you can see here a worm, which is essentially a screw having one or more number of helical threads on it. Yes, this is the worm, and here this is the worm on this diagram. It is essentially a screw, will be in the shape of screw having one or more number of helical threads cut on it. You can see that one or more number of helical threads on the threads are made on this worm. Next is worm wheel. It's a worm wheel with a helix tool profile which engages with a worm. This is that worm wheel actually. In this diagram, this is the worm wheel with a helix tool profile. Yeah, helix tooth profile. Sorry, this should be tooth profile. This is helical tooth, similar to that of helical gear. Helix tooth profile which engages with this worm. So as already you can see there, we have a worm which is having that, which is in the shape of screw, or you can say it as it is having one or more number of helical threads, and this worm wheel with a helix tooth profile will engages with this worm. And worm gears are suitable when large gear reductions are needed. Using worm gears, gear reduction of 20:1 to 300:1 can be obtained. So if you want to decrease that speed, or if you want to reduce that speed there, we will make use of this worm gear. So that is our main use of this worm gear actually, when that gear reduction is required, and we will make use of this worm gear. So this is the worm, and this is a worm wheel. You need to write this simple diagram for this worm gear. Write that this gear is used to transmit the power between the driving and the driven shaft, having their axis at right angles, and they are non-intersecting. Which is essentially worm is essentially a screw having one or more number of helical threads cut on it, and worm wheel with a helix tooth profile will engage us with a worm, and thereby which power transmission will be taking place. These worm gears will be used when the large gear reductions are needed. So using the worm, gear reduction of 20:1 to 300:1 can be obtained. You can see there RPM of 20 can be reduced to 1 by making use of this worm gear. The speed can be definitely reduced by making use of this worm gear. Next, we will have that rack and pinion gear. So this is a simple diagram for this rack and pinion gear. I think you all are familiar with this rack and pinion gear. When a rotary motion is to be converted to linear motion, or linear motion is to be converted into rotary motion, rack and pinion gear arrangement is used. So this is to convert a linear motion into rotary motion, or to convert this rotary motion into linear motion. A rack is a gear having teeth cut along the straight line. We have the rack with a gear having, it's a gear having teeth cut along the straight line. You can see that rack here. And this is the pinion, is a gear with teeth cut along the periphery. Yes, the teeth are cut along the periphery. Here this is the pinion, and the teeth will be cut on its periphery. So they are used in a machine tools such as lathe machine, drilling machine, and milling machines. So this will be used in that machine tools like lathe machine, drilling machine and milling machine. You will see this lathe, drilling, milling in the next module. Actually we don't have drilling, we will have only lathe machines and milling machines. You will come to know what are those machine tools and all. So this is regarding rack and pinion gear. So next, it is a very easiest thing and you can easily write regarding this rack and pinion gear, and this is a simple diagram you can see there. So this is the movement of the rack in the towards the left. Due to that movement of this rack, it will engage us with the teeth of this pinion and make the pinion to rotate in the clockwise direction. This leftward movement, clockwise direction. If you want to move the rack to the right side, then definitely it will engage us with the teeth and make the pinion to rotate in the anti-clockwise direction. So next, let us move to advantages of gear drives and disadvantages of gear drive. First, let us begin with advantages of gear drives. This is the most convenient for small center distances, as I said in the first introduction itself. So the gear drives will be used only to transmit the power when the center distance is very small. Yes, this will be most convenient for very small distances. Next, can be used to transmit the power between two parallel, non-parallel, intersecting and non-intersecting shaft. So whereas in case of belt drives, you can transmit the power only when between the two parallel shafts there, whereas here in case of gear drives, you can transmit the power between the parallel shaft and between the non-parallel shaft, as well as intersecting and non-intersecting shafts. Next, where this transmission efficiency is very high, they have high transmission efficiency, that is these gear drives have high transmission efficiency. Next, they can be used for high, medium and low power transmission. So this gear drives may be used for high power as well as medium or low power transmission. No restrictions for this gear drives here. Next, power can be transmitted with a constant speed ratio. Yes, that is we discussed in the definition itself, that power can be transmitted with almost with a constant speed ratio. Next, let us come to the disadvantages of the gear drives. These gear drives are not suitable for the shafts of larger center distance. So we cannot design that gears of very bigger size and we cannot make them to mesh with one another. Instead of that, if the center distance is large, then we will go for belt drives instead of this gear drives. So not suitable for the shaft of larger center distance. Next, these gear drives always require lubrication. Yes, you all know that as the teeth mesh with each other, there should be proper lubrication. Otherwise, there will be wear and tear of the teeth may takes place. So it may affect the entire setup or entire arrangement there. Next, noise and vibration is a major problem when they rotate at higher speeds. Yes, these gears, in case of gears, as the teeth mesh with one another, like teeth of the driving gear will mesh with the teeth of the driven gear. So due to that, when they rotate at very higher speeds, it will cause definitely the noise and vibration. So that's why they are telling it as noise and vibration is a major problem when they rotate at higher speed. Next, cost of production of gear is high. That is definitely this is regarding cost of production of the gear is very high. Next, damage to a single tooth affect the whole arrangement. If any one tooth of that gear drive gets damaged, then definitely that it will affect the entire arrangement, whereby which power transmission will not be taking place effectively. So even if that one tooth get damaged, then that entire gear wheel has to be replaced. So that's why they are telling it as damage to a single tooth can affect the whole arrangement. Yes, this thing is enough for today's class.